So in this video, I'm going to go over some of the scripts that you can find in the folder helperScripts, which is in the fNIRS preprocessing folder. So I'm going to go ahead and open this up, and what you'll notice first is that there's an in development folder, which means that whatever's in this folder is not fully working yet, so I don't recommend using it. And then we have some files, some of which I actually have a separate video for. So I just want to be clear that for the manual preproc and function preproc, these are alternatives to running the preprocessing script to the run NIRSpreProc, which is like the main selection. So if you want to understand these two scripts, I would go to a different video, which is called preprocessing fNIRS with manual inputs or as a function. So what I will be going over is channel loss only, compile only, and MNI table maker. So let's first go to the compile only. So let's say you ran your preprocessing, but for some reason you didn't compile all the data, but now you want to. So I think I go over this actually in one of the other videos, but just so we have it here, it's really helpful. So maybe you collected your data and preprocessed some of it, and then you collected more data and then preprocessed more of it, and so you didn't compile all at once. So here, I've already preprocessed this data. It's for a hyper multi-scan. So we have a dyad, we have two subjects, and then we have 3 scans. And then within the scans, we have our preprocessed data. So what I want to do is I want to take all of the data that's been preprocessed for each subject, each dyad, each scan, and then just put it all into one .map file that I can work off of. So once I get to analysis, I don't have to iterate through all these folders to get each individual scan's data. So I'm going to open up this compile only, and I'm going to change the properties or inputs to match this study. And I've already done that, but just so we can go over it, so my data prefix is HM for this, as you can see. And then our ID length is always going to be the number of characters after the data prefix, but before the scan name. So here it's 5. And then my channel rejection that I want to compile, because there are 3. So let's just go over that for a second. We have our no channels have been rejected, which is this first one. Don't recommend compiling that because it has oversaturated channels. It's really just there if you want to compare. This would be no noisy channels, so we're going to actually just make any channel that's oversaturated into nans. And then we have our no noisy or uncertain channels, meaning any channel that was oversaturated is a nan, and any channel that has a ton of variation that doesn't align with the normal cortical activation, so we consider it to be uncertain even after motion correction, is going to be nans. So for channel rejection, it's just 1, 2, or 3. So I'm going to say let's compile just the noisy channel rejected. So that's going to be 2. So it's a hyperscan, so I'm going to put 1 for yes, I scanned multiple subjects at once, and then it's going to ask me how many scans do I have, and so for this study it is 3, if I remember correctly. Yeah. So 3 scans. Whether I want to do z-score or not, that's up to you. And then if I want to do a channel loss check, so basically, do I want to add to my compile .mat a extra variable or variables if you hyperscanned that tell me which channels were lost in every subject? So I'm going to say, yeah, let's do that. So once I set the properties, you don't have to change anything else. Even if your folder is not active in your path, that's okay. Once we hit run, it's just going to ask, and we're going to say, yeah, add all the folders and subfolders, or at least the ones that I need. And then it's going to say, okay, where's your data? So I go to my desktop, and it should be this NIRS. And what you'll notice is I'm not clicking on the preprocessed, I'm just clicking on the overarching folder. And so now it compiled. And if we want to double check, right now it's just outputting everything. So that looks great to me. I have my 3 scans, my subject 1 for all dyads, as well as time, triggers, auxiliary, and I have my subject 2 for all dyads, time triggers auxiliary, sample rate, and then that variable for subject 1 all dyads and subject 2 all dyads, channel loss. And just so we can look at that, that's subject 1, that's subject 2, and a 1 means yes, I lost that channel. We have 42 channels, so it's going to go all the way down. How you use any of these variables is up to you, but just so you know, for like channel loss, maybe you want to get an idea of like how many times did I lose channel 1 across like subject 1. You could do something like this in your command window, or if you want to write a script, it's up to you. I could say, okay, for scan 1, it's going to be, and I don't want to do subject 1 because that's the data, but lost subjects by channel. So lost subjects by channel, and for subject 1, then I want to do for all subjects, channel 1, summit. So that means I just lost one channel. So what did I do here? I said for the first scan, I want to look at, for subject 1 of the dyad, all subjects. So if I have like 50 dyads, channel 1. If I wanted to look across all subjects and all channels, I could do something like this. So here, I'm not looking at a singular subject, I'm looking at how many times I lost the channel across subjects. So you can see down here for channel 41 and 42, I lost that channel in both of the subjects. That's a bummer, not surprised because that's in the very back of the head where it's really thick, but that's just a way of like kind of getting at your channel loss if you want to just use the Oxy 3D. That being said, I'll just clear this up real quick. Go to my overarching preprocess files. So there's that compile now. But we also have these two CSVs that it makes based on your channel rejection. So let's take a look at those. So this is just like a different way of looking at your channel loss. So if I actually go down, so for that first scan, channel 41 and 42, just like it showed in my command window earlier, we lost both subjects for that channel in that scan. So if I also look at this one, so that's all channels. Now we can look at subjects. So we have dyads, just FYI, if you didn't do hyperscanning, it would just be subjects. But we have dyad 1, subject 1, dyad 2, subject 1, dyad 1, subject 2. So that's just the organization. And then you have your scans. So we can see for dyad 1, subject 1 and 2, for that first scan, they both lost 2 channels. Alright, so that's just like a different way of compiling it for you to understand your channel loss. It's up to you on how you want to use it. You could also do, so let's just say, I don't like the way those are, and instead I want to just make some CSVs of the channels that I have. So what I'm going to do is open up this channel loss only. So again, you're going to want to set your properties. So HM is hypermulti, that's for this one. It's a hyperscan, it's a multiscan. My ID length is 5, my number of scans is 3. For this one you do have to set the channel number, so I know that it was 42 channels. Alright, so I'm going to hit run, and it says choose your pre-process data directory. So just keep in mind, this is not the overarching, but instead the folder that says pre-process files. Sorry I made those different. Alright, so I select it, and now it's just generating data quality reports, which are just going to be CSVs. And you'll notice also that it says 2 out of 3. That is because the way that this does this is based off of how many like objects that start with the data prefix are in the folder you selected. So what does that mean? Well, in my preprocessed files folder, I had 2 dyads, but also this compile. And so it actually checks for the compile and ignores it, just so you don't error out. Alright, so I have these 4 CSVs that I just made, And what it's doing is it's giving me the noisy channel rejection as well as the noisy and uncertain. No need to do no rejection, as that would just be all channels. So if I open up all subjects, clean channels, we're going to see for my diodes and my subjects, as well as my scans, how many channels I still have. So instead of it being how many did you lose, it's telling you how many do you still have. If I compare this, let's see. Let's do clean and certain. There we go. All right. So what you'll notice, so this one is just the rejection of noisy channels, meaning I've rejected any oversaturated channels, whereas rejection of noisy and uncertain. So now if I also reject these channels that seem uncertain even after motion correction, you'll kind of see a difference. So here, for like this subject, they had all 42 channels across all of the scans, but now for this last scan here, they're actually missing a channel. Same with this subject here, they had 38 when we were just rejecting those noisy channels, but now if we also reject those uncertain channels, they only have 31 channels. This is really up to you if you want to use the uncertain. It depends on if you think that the uncertainty is due to motion. It's there as an option. And this is just a different way of looking at your channel loss. So same thing again, just a different way of looking at it. And what this is saying is how many subjects do you still have for that channel in scan. So for channel 1, in the bonding, the first scan, I have only 2 subjects, meaning I've lost 2. If we look at channel 5 in the second scan, I only have 3 subjects, meaning I lost 1 of them because I have 2 diodes and 2 subjects per diode. So there's just a different way of like compiling. Do you want to look at how many you lost, or do you want to look at how many you have left? Alright. So that's for the CSVs, if you want to just run those. So channel loss only will give you how much do you still have, whereas the compile only will add it to your compile, but it will tell you what you lost. So hopefully that makes sense. Alright, so I have a habit of doing clear. So I have one other thing to go over here, which is this MNI table maker. So for the most part, when you pre-process, it's going to give you an MNI channel table. Let's see if I have some pre-processed data with it. I've deleted it all. Oh, here we go. Okay. So for this pre-processed data, if I go in to the actual subject scan, you get this channel MNI coordinates. And what that is it takes your probe info file and it takes each of the channel's coordinates and transfers them into MNI coordinates, which is really nice because then you can visualize things and share them in this MNI space. So like this one has 42 channels. So like this is my 42nd channel in XYZ. However, every once in a while, depending on how you collected the data or if you're missing some things, it might not do it. So for this one, it's with the NIRS Scout. And oops, let's go to my pre-processed. If I click in, I don't have that channel MNI coordinates. And that's because when I use the probe info file from NIRS Scout, it doesn't output the digital points. So if I actually go into the raw data, you'll notice there's a probe info file, but there's no digital points. That's because the digital points come out when we export to Aurora. So this is all very specific to the NIRS software and whatnot, so if you're not using NIRS, I'm sorry. Some of this probably won't work. But what I can do to get those digital points is this is kind of my little hack, in that I will open NIRSite. So NIRSite is where we make our probes for NIRS data. So I'm going to load from my existing data. Just go into any scan. I'm going to load that probe info file. look at it. All right, looks great. And then I'm going to save it and export it to Aurora. So instead of going to NIRS star, which we use for the NIRS Scout, I'm exporting it to Aurora, which is what we use for the NIRS Sport. You could name it anything you want. It doesn't really matter. I'm just going to say like probe for example. All right, so I'm just exporting this to Aurora. I save it. And I actually don't even need to open Aurora. I'm just going to go to my NIRX folder, wherever you have it, configurations, montages, and we called that one, gosh, I've already forgotten what I called it. Oh, probe for example. Okay, so probe for example, and boom, we got digital points and the probe info file. So what I'm going to do is literally just copy this probe info file, throw it into this folder, as well as my digital points. So now it's in this overarching folder, and I can just run this MNI table maker here. So just as an example, your probe info file should be called standard_probe info, and digital points should be just digital points. As that's how the script works. But you don't have to change anything. There's no inputs here. You just hit run. It's going to ask where your data is. So that overarching folder. And it's very quick. Again, it's also outputting things right now. So if we want to just double check that things went well, we can kind of look at this table. That looks pretty good to me. I had 42 channels. Those look like MNI coordinates. We can also look if it's saved. And it did. So now we have the channel MNI coordinates.csv. Perfect. You could do this even if it made it for all of your subjects. If you just want to have it like in your overarching folder, you can also just copy it from any of the scans if it created it during pre-processing. It's up to you. But it's there if for some reason it didn't make those MNI coordinates. Is this kind of standalone MNI table maker. So hopefully that's helpful. So like if for some reason you forget to compile or it didn't make that MNI coordinate table, or you want a different way of understanding your channel loss, and you don't want it to be what channels did I lose, but instead what channels do I have, you can use these kind of standalone scripts. Alright, so hopefully that was helpful. That is it for this video.